Introduction to Soldering Techniques for Electrical Engineers. Welcome, electrical engineers. Soldering is a fundamental skill for building reliable and robust circuits. This video will equip you with the knowledge and techniques to master this essential craft. Gearing up, tools of the trade. Before we dive in, let's gather the necessary tools. Soldering iron. This is your heat source, melting the solder to form the connection. For most electrical work, a 25 to 40 watt adjustable temperature iron is ideal. Solder, lead-free solder is recommended for most applications. Choose a thin diameter, around 0.032 inches, for precise work. Solder wick. Optional. This handy tool helps remove excess solder or correct mistakes. Diagonal cutters, for trimming component leads and excess wire. Safety glasses, protect your eyes from splashes and hot solder. Helping hands, optional. This tool holds your components in place for easier soldering. Preparing for takeoff, surface prep is key. Cleanliness is king. Use isopropyl alcohol to remove dirt, oils, and oxidation from the component leads and PCB pads where you'll be soldering. Rough up the surface. For a stronger connection, lightly scratch the component leads with sandpaper to create a slightly rough surface. Soldering like a pro, the art of the perfect joint. Tinning the iron. Apply a small amount of solder to the tip of your preheated soldering iron. This creates a good heat transfer surface. Heat it up. Touch the soldering iron tip to the component lead and PCB pad simultaneously. Heat them for a few seconds, allowing the solder to flow freely. Solder flow, not solder blob. Apply the solder spool to the joint, not the iron tip. The solder should melt and flow onto the heated surfaces, creating a smooth and shiny joint. Less is more. Avoid using an excessive amount of solder. A small, well-defined joint is ideal for optimal electrical performance. Let it cool. Allow the soldered joint to cool down naturally before moving any components. Common pitfalls and how to avoid them. Cold solder joints. These occur when the solder doesn't properly melt and form a strong connection. Ensure both the iron tip and surfaces are hot enough for the solder to flow freely. Solder bridges. These are unwanted solder connections between nearby components. Use a steady hand and apply the solder precisely. If you create a bridge, use solder wick to remove the excess solder while the joint is still hot. Overheated components. Excessive heat can damage delicate components. Use the appropriate temperature setting for your soldering iron and avoid prolonged heating of any component. Practice makes perfect. Don't be discouraged if your first attempts aren't perfect. Soldering takes practice. Try your hand on some scrap components before tackling your actual project. Bonus tip. Always keep your workspace clean and organized. This will not only make soldering easier but also prevent mistakes.